When you're programming, you'll find yourself dealing with errors all the time. But that's okay, because errors crop up all the time everywhere. We misjudge the sizes of things or how long things take. Errors are nothing to get worried about. You find them, you fix them, and you move on. Errors in computer programs are often called bugs. There are lots of urban legends, each one of which purports to tell us where the word bug comes from, and I don't know which of them are true, if any of them, but it's now the language everyone uses. The key thing about finding an error is getting the right point of view. The driver of this car can work the pedals all he wants, but he won't see the problem until he gets out of the car. It's a similar situation when you look for a bug in your own program. You might find yourself looking and looking and looking until you have just the right point of view. Then it's obvious. Often bugs are completely mysterious until you suddenly see them. And then there's this aha moment, and you find it amazing that you could have ever missed the problem. Things can go wrong in two different ways when we're working with processing. The first comes after you press the run button, but before your program actually starts to run. The second type of error appears when your program is running. They're distinctly different types of errors, so we'll look at them in turn. A little background will help you understand the first problem. When you press run, the computer takes a snapshot of the processing program currently in the text editor, and then it translates that program into another language. This other language is called Java. The reason for this translation is because the computer is better equipped to run Java programs. So just like you might translate a book from French into English, your program is automatically translated from processing into Java. If something goes wrong during this translation step, processing reports the error and stops. Your program never even starts to run. This is the first kind of error we'll discuss. These errors are usually due to typos in your program. That is, they have to do with the words and punctuation that you typed in. Collectively, all the stuff you type in is referred to as syntax. So if you type in some words and letters that don't conform to the rules, processing notices this during the translation step and reports an error in your syntax. Naturally enough, these errors are called syntax errors. Here's a processing sketch, and I will deliberately make a syntax error. I'll try to print out the word hello, but instead of saying print, I'll say prin and leave off the T. Notice that because prin isn't a keyword, processing hasn't turned it orange. That's a clue that we've done something wrong. But this kind of error happens to everyone all the time. You leave out a letter, you type the wrong letter, you leave a letter out. Whatever goes wrong, processing notices this during the translation stage and quits. Let's run this and see it happen. We can see that processing is reporting a problem. It tries to guess where things went wrong, and it highlights that line in yellow. Then the message area turns red, and it prints out an error message telling us what it thinks has gone wrong. In this case, the function printString does not exist. Well, that's a pretty good message. It's not perfect, but the computer can't read your mind, so it can't say, I know you meant print. All it can do is to say, you're calling something called prin, and I've never heard of that. If you're like me, you'll read this message and think, what? Prin? What's that? Then you look at your code and you see the typo, and the message makes more sense. When processing reports one of these errors, it usually prints out some additional detailed information in red in the output area at the bottom. I suggest just ignoring all this red text. This is a detailed error report describing what went wrong during the translation step. Personally, I almost always completely ignore this red text. The best place to look for information on what went wrong is the status bar below the text editor but above the output area. This contains processing's best guess at the nature of the problem. So let's fix this bug by adding the missing T. Now when I run the program, the status line goes from red back to gray, the output area at the bottom is cleared of all that red text, and instead we see white text with our little message, hello. Now that our program is running, we won't get reports of any more syntax errors. We're done with the first kind of error. If anything goes wrong from now on, while the Java program is actually running, we get what's called a runtime error, which just means it's happening during the time when the program is running. These kinds of errors arise not from typos, but when you accidentally ask the computer to do something it just isn't able to do. Let's look at an example. To make a good runtime error, I'm going to have to use some language features that we haven't seen yet. So I'm going to type some stuff that would look unfamiliar to you. Don't worry about it. The point of our discussion now isn't the program itself, but how processing reports a runtime error with the program. The runtime error that I'm going to create has to do with lists. I'm going to create a list of 3 integers. Then I'm going to ask processing for the 4th value in the list. Well, there is no 4th value, so processing will quit and report an error because this is an impossible request. There is no 4th element in a list of 3 objects. Processing considers this request so impossible to fulfill that it stops the program and reports it as an error. Here's the program. Again, don't worry about the specifics. We'll talk about lists in detail later on. But generally, the first line creates a list of 3 integers. The second line prints hello. The third line asks for the 4th element in the list and tries to assign it to the integer val. Now, don't worry that the number on this line says 3 rather than 4. We'll discuss that later. We really are asking for the 4th element in the list. Then the 4th line prints out the value in the variable val. Well, we know what happens when we press run. The program is translated into Java. This happens without any trouble. There's nothing wrong with the characters we've typed. So the translation finishes and the Java program starts to run. It makes the list. Then it prints out the word hello. And then it tries to retrieve the 4th integer from our list of 3 integers. The result is a runtime error. As before, the status bar turns red and reports an error message. And the output area at the bottom fills up with tiny red type, which we can safely ignore. The error message in the status bar now reads, array index out of bounds exception, 3. In the language of lists, which we haven't discussed yet, that message is saying that we're asking for an element in the list that goes beyond the 3 elements that are present. Well, it's not the world's most helpful error message, but once we know about lists, you'll find that this is a good start, and we can go out and try to fix the problem. As with syntax errors, we can look at our code, make changes that we hope will fix things, and then run it again. Errors of both kinds, syntax and runtime, crop up all the time. Sometimes you make a great plan, but for some reason you don't carry it out as you originally intended. Check out the door on the left side of this house. You'll frequently find that errors catch you by surprise. So suppose that you run your program and it works great. Well, you leave for a while and then you return and something has gone wrong. Or sometimes great theories don't turn out well in practice. There's a video on debugging, the process of using print statements and comments to identify and catch an error. When you're looking to fix an error, make sure you take advantage of processing's hints, the message in the status bar, and the line that processing highlights in yellow.